Hey guys, thanks for liking, commenting, subscribing, sharing these videos. And in this video, as I said, I'll record one more video of Pinacol formation. This is the part 2 of this video. Okay, part 2 of this video. If you have not referred part 1, please refer part 1. It will be very useful for you. Now in this, I'm just picking a few new questions. This is OH given to you. And can I say again, if you revise that video, previous one we have said this is 6 member and 6 member. The first thing is making OH2 plus, and the next step OH will push and the bond will open. So one can become 7 membered and other will become double bondo, right? So it's a 7 membered and 6 membered ring we are going to get in this answer. Check question number 8. So till 6 I have discussed in the previous video. Please refer that video, then it will be more meaningful. Now, as I said, Pinacol formation reactions are very important, and we have to check the first thing as stable carbocation. Stable carbocation. So let's revise a little bit for the newcomers. And the next part is AR, HR is the sequence. Under AR also, those groups which are electron pushing groups will be better options than electron withdrawing group. So this was the learning in earlier portions. So we can say in this video, if you observe, this is a plus charge at this place, okay, somehow. So how many alpha H are there? 1 H is here and 2 H are here. Total how many H are there? 3 H are there. Whereas if I take in other side, let's say at this place plus charge. So you have 2H here and 2H here, right? 4H. So which side is preferred? We know that the more alpha hydrogen is linked with the more stable answer. So we'll say that fine, H plus I'll take from this side. If you take H plus from this side, what will happen? Once you take H plus from this side, what will happen? Can I say this become OH2 plus? Plus charge will come here. And in the next step, this OH will be behind migration part of this whole thing. So we can expect this answer which I have drawn. Remember, the migration will happen from that side where Me is present, not from this end. So I'm not migrating this end, rather I'm migrating the other end. And I hope you understood the answer. This will be a 6 membered ring, 5 becoming 6 and other 5 remain as it is. Now, let's see a few more questions here. So we'll pick one by one these questions and try to solve these particular questions. Question number 1 is reaction with HNO2 in and then followed by minus H plus. So I'll just take this question and I'll just try to solve it here. I'll take some more space. Yeah, so let's do this. So in this question, what we can do is, this is the first one. So we can say that OH is given and HNO2 is given. So HNO2 and NH2, whenever you see this thing, always remember that this is going to become PH, this part is Me, hydrogen, and this is N2 plus. Or if you can draw, if you have a problem with this, you can draw like this as well. PH, OH, N triple bond N plus, H and Me. This also we can draw. Both are okay. Now in the next step, what will happen? In the next step, we can say this is our leaving group ready. And the force behind pushing this thing is OH. And the migratory group is PH. So there's no confusion about it because both are PH. So what will be the result? End result, PHC double bond OH plus. And at this place, what we have? We have one Me. We have one H. We got one PH also. And N2 comes out. At the end, we can say H plus leaves to make the system stable. And my answer comes out as PHC double bond O, PH, Me and hydrogen. This is your final answer. So the C answer is this. What about B? B was this part basically till HNO2 portion, and we can complete this question. Next question was, we'll take up the next question. Next question is this one. So let's take this question now. Okay, in this question, what is to be done? Okay, let's see this question first. Okay, so we have been given a cyclohexanone reacting with CH3NO2. So you should understand what is the language of question. That is, see, my aim is never to make you learn these things as in like you mug it up. Rather, my aim is that you understand this question. You can solve n number of questions of this type next time without anyone's help. That's the aim. So you can become self-reliant. That's the aim, right? CH3NO2 is this compound. When we talk about ETO minus, which is acting as a what you call strong base, can pick this hydrogen, and meanwhile you can see this kind of transformation here. So it will become CH2 double bond NO minus coordinate. Those who have problem with these things, they can simply say this H has been taken and the compound has become CH2 minus NO2. That's also okay. But remember, there is no logic of carbon carrying this negative charge because O is present and it will definitely go to oxygen. So this is the right way to write. Otherwise, if you're not feeling comfortable with that, I'll say, okay, fine, you can just do it like this also. That's fine. That's okay. Okay. So this is the ready carbon ion and this is a ready carbon ion which is ready to attack on C double bond O on this cyclohexanone. So option number 1, we can show it like this. And those who have problem, for them we can directly go and attack like this. That's also fine. Is that clear? So I can just, this is too long arrow, so I'll just keep it short. I can bring it here, let's say, and let's say we attack it like this. So this or this, both are okay, but I'll prefer this because this is more logical and more systematic, okay, and more correct also technically. So when you attack, this will break towards as O minus. So we have connection of CH2 and NO2 like this. This much all of us can do. So this is product number B we have right now with us, right? In product number B, we can say H plus can be taken away. So where is H plus? That H plus which ETO has taken as ETOH can be again taken back by this, and we have B as our final answer, something like OH. You can draw OH, CH2, NO2. This is your B. So this is done. Now B is reacting on LAH. That is the next part. So what is LAH known for? Revise it. LAH is known as a reducing agent, which is for polar bonds. And what is the polar bonds in this case? N double bond O, coordinate O. This is a polar bond. So if this is the situation, we can say this structure which is given can become OH, and this is CH2 NH2. That we can draw OH CH2 NH2. So the next step is, once you get this, reaction is happening on HNO2. So reaction is happening on HNO2, and we know that RNH2 and HNO2, they will always try to give us N2 plus. So OH CH2 N2 plus will be given. So what's the final answer? In this case, O will push, and now ring opening has to take place. So we can open this kind of way. This ring can open and N2 can leave in this case. So what's the end result of this whole discussion? End result will be that double bond OH plus is formed, and we have, double bond OH plus is formed, and we have connection of this with CH2, right? So it's like extra connection. So if you count, number of carbons will be increasing now. So we can say this is the structure. Now normally we can say this is a CH2 here, so we can say CH2 and then this. So 1, 2, 3, 4, 5, 6 and 7 members we can show. At the end, this H plus will leave, and we have the final answer as C double bond O. Look at this, 1, 2, 3, 4, 5, 6, 7. So if you observe, we have drawn cycloheptanone. Be very clear. 3 plus 4, 4 corners we have, 7 corners, right, total. So this is the final answer for this question. Look at this question, and that could be called D. I think you understood this question. We'll pick next question now. Next question is simple here. We can just take this one. This was the next one. Okay. So these are few very good questions that you can try and practice. So the question goes like this. We have a diketone. If you observe, this is a diketone. And on this diketone, they are reacting MgHgH2. So what's the role of MgHgH2? As we know, MgHgH2 is known for formation of Pinacol. So we can draw the whole structure something like this. C double bond O, Me hanging here. 1, 2, 3 members. And C double bond O, 1, 2, 3 members. And then C double bond O and Me hanging here. 1, 2, 3 carbons in between. 1, 2, 3 carbons in between. So when you talk about this reaction with MgHg water, can we say this will form radical? And once it form radical, you know the whole story, what will happen? So we can say 1, 2, 1, 2, 3, 4, 5. It will become a 5-membered chain like this. In that chain, one Me is hanging, one OH will hang, one Me is hanging, one OH is hanging. Please revise this, we have done in the part 1 in detail. So after you do this, the next step is H2SO4. So H2SO4 is providing you H plus. And what is the final answer we can expect? This is OH2 plus. So plus charge is formed, and later this O can push. Which group will migrate in this case? Me can migrate, and later water can come out. So I hope you understood the steps. Me can migrate and water can come out. So what's the final answer? You have a 5-membered ring with 2 Me's coming to it. All right. Or I think I should put it here so that you should compare it properly. Let's say both the Me's are here, and this place we get a double bond. So this is your final answer that we achieve. Okay, it's again a ketone. So I hope this question is also clear, and we can learn many such questions without any problems now. Now next is this example. We'll take this example. So in this example, So this is simple. We can say MgHg water will give us this kind of Pinacol, and this kind of Pinacol you have already solved. What will happen with this kind of Pinacol, which is this product? So with this, we can say one will be a 6-membered ring, one will be a 7-membered ring, and we can take a call accordingly. So 6-membered ring and a 7-membered ring. The one which has pushed is this one, and this kind of answer we can draw with a 7-membered ring with a double bond O and then a 6-membered ring. I hope you understood all these questions. Please keep liking, subscribing, sharing and commenting. Thank you very much.